All right, look, welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the channel. Make sure you like this video. Make sure you share this video with somebody. And also, if you got any questions about anything that I attempt to explain, make sure you put your questions in the comment section down below. All right, now we are about to factor by grouping. All right, now we factor by grouping when we have an expression that has 4 terms, maybe 6 terms. Even though for the most part, I've only used this when I've seen expressions with 4 terms. I don't typically see expressions with 6 terms or 8 terms, but I'm sure you could use it with that many terms. But anyway, we got 4 terms here. Let's first make sure we understand that. 2y squared is our first term. Az is our second term. Negative 2z is our third term. Negative ay squared is our fourth term. So we got 4 terms. Now, why is it called factoring by grouping? Because we're going to create 2 separate groups. Each group's going to have 2 terms in it. All right. Now, with this particular problem, this is a little different from some of the other problems I've done that are on this channel, right? Because if I was to make a group with these first 2 terms, there's nothing in common except 1, right? Because that's a 2. That coefficient is a 2. This coefficient is a 1. The common factor of 2 and 1 is just 1. This has a y squared term. This does not. So that means y is not common. This has an a term. This does not. That means a is not common. This has a z term. This does not. That means z is not common. So these 2 terms, if I was to make a group out of these 2 terms, they ain't got nothing in common. They ain't got nothing in common. So we not gonna be closer to our factored form of this expression if I group those together. But that's why you gotta also take a step back, look at all 4 of your terms and say, oh, what if I rearrange some things? You know what I'm saying? What if I rearrange some things? Like, what if I put this 2y squared with this negative ay squared? What if I put this az with this negative 2z, right? Or what if you put this 2y squared with this negative 2z, and you put the az with the negative ay squared? Then you'd come up with some common factors, right? Besides 1. Because if your common factor is 1, that don't change nothing. That's not going to help nothing, right? So that's something you got to look out for. You got to look out for that when you are factoring by grouping. You might have to rearrange the terms so that you can find groups that have a common factor. I'm going to say that again. Something you got to look out for when you're factoring by grouping. You might have to rearrange the terms, right, in order to be able to create groups, or in order to have groups that have a common factor. So let's do this. Let's rewrite this. So I'm going to do 2y squared. I'm going to put this with the minus 2z. And then I'm going to have plus az minus ay squared. So it's not a new expression, because I mean, it's the same expression. I just rearranged some of the terms. All right. So now I'm going to make my 2 groups. So I'm going to do like this. That's my first group. This is my second group. So now I got my 2 groups, right? So I look at the first group, which says 2y squared minus 2z. Now, I got a 2 for a coefficient and a 2 for a coefficient. Really, it's a negative 2, but I'm not worried about the fact that it's negative. So I got 2. Y is not common. Z is not common, because only this term has a y. This don't have no y. Only this has a z. This don't have a z. So 2 is my GCF. Because remember, matter of fact, let me not remember, because I ain't say it yet in this video. When you factor by grouping, you create groups. Actually, I did say this already. So yeah, I'm going to say it again. When you factor by grouping, you create the groups, and then you find the GCF, the greatest common factor of each group, and you factor using the GCF. That's what you do. So we're going to have 2 times a binomial. What goes inside the parentheses in this binomial? The quotients when you divide each term by the GCF. So 2y squared divided by 2 is equal to y squared. Negative 2z divided by 2 is equal to negative z. Why is that? Because what happens when you do 2 divided by 2? That equals 1. Then you have 1 times the y squared that was left, which is y squared. Then you got negative 2z divided by 2. Negative 2 divided by 2 is negative 1. Negative 1 times the z that was left is negative z. Boom. Then you go over here. What's your GCF for these 2 terms? Plain old a. not z, not y, because z and y aren't common. They're not in both terms. Notice how this got an a in it and this got an a in it. So a is common. All right. So then we put the parentheses and then we divide. Az divided by a is just z. Because what's a divided by a? 1. And then what's 1 times z? Z. That's where the z come from. Then you do this, you divide this by a, you're going to have negative y squared because a divided by a is 1. And then the 1 times the y squared is y squared. But really it's negative a divided by a. So that equals not positive 1, but negative 1. Then you take the negative 1 multiplied by y squared. That's how you get this. Now, this is something else you got to look out for when you see problems like this. Peep what's inside the parentheses. I got y squared minus z in this binomial, but then I got z minus y squared in this binomial. I got the same terms, but they got opposite signs. This has a positive y squared. This has a negative y squared. This has a negative z, but this has a positive z. Whenever you see that happen, you can factor out a negative 1 in order to get the signs to switch. Because that's what you want. Because when you're factoring by grouping, you want the binomial you end up with, the binomials, I should say, to be identical. Identical. These are not identical because the signs ain't right. Right? So watch what I do. I'm going to rewrite this. This ain't going to change. But then over here, watch this. Watch this. Plus a times negative 1 times negative z plus y squared. Now, look at how this is different from this. Look at what happened. What did I do? I factored out a negative 1 because positive 1 is a factor of everything. Negative 1 can be a factor of everything as well. So because I know that, right? And this is what you do whenever you factor in by grouping and you got the same terms with opposite signs. So make a note of that. Write that down in your notes. When you see a situation like this, when you got the same terms but with opposite signs, you can factor out a negative 1. So if I factor out a negative 1 and then I divide each of these terms by the negative 1, what is z divided by negative 1? Negative z. That's where the negative z came from. What is negative y squared divided by negative 1? Positive y squared. That's where the positive y squared came from. Now, another thing you got to keep in mind. Why did I do this? Why? For what point? Because I need, when I'm factoring by grouping, I need my binomials to be identical, right? So now, even though the order is different, I got a positive y squared here. I got a positive y squared here. I got a negative z here. I got a negative z here. So the order is different, but now it's the same expression. And because of the commutative property, something else you probably heard of before. When the order is different, the value of the expression is the same. All right. But if you want to, we could rewrite this and let's clean it up. Let's do that. So again, this first part is going to be the same. It's going to be 2 times y squared minus z. And then I'm going to clean this up. This is going to become minus a. Why? Because what's a times negative 1? Negative a. So plus negative a is the same thing as minus a. Again, plus negative a is the same thing as minus a. And then I can change the order around to make this one look just like this one. This one can look just like this one. Y squared minus z. Now it matches up. So now it matches up. So now make sure you understand what happened, right? Make sure you know where the negative 1 came from. I factored out a negative 1 from this expression because negative 1 is a common factor of everything, just like positive 1 is a common factor of everything. So this is what we call a mathematical tool. It's a strategy, right, that you got to know. Because if you see a situation like this, just know, factor out the negative 1. That's what you do. It's like a cheat code for a video game from back in the day. Just factor out the negative 1. When you got an expression that you want it to match up and be the same, but it's not, but you got the same terms, but opposite signs, just factor out a negative 1 on one of them. You know what I'm saying? Now, I could have also factored out a negative 1 from the first expression. And then I would have had positive, this would have became positive z, this would have became negative y squared. And then it still would have matched up. So either way, you got to factor out a negative 1 from one of these binomials. All right. So then I end up with negative minus a, because a times negative 1 is negative a. And then I just switch the order around, which I can do because this is addition. This is still positive y squared, negative z, negative z. Now I take the GC. Now I got two terms. This is really a binomial. This is one term. 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 So I got a GCF, which is y squared minus z. That's what they both have in common. So y squared minus z is my GCF. And then next to that, I'm going to have a binomial. Now, what goes in these parentheses? The quotients when you divide this term by the GCF. So 2 times y squared minus z divided by y squared minus z is just 2. Why is it just 2? These are the questions you should be asking when you watch your teacher at the board, when you watch your professor at the board, when you're watching this video on YouTube. These are the questions you should be asking. It's just 2 because what happens when you do y squared minus z divided by y squared minus z? That's equal to 1. That's just plain old positive 1. And you had a 2, so you got to do the 2 times the positive 1 you ended up with, which is 2. So that's why it's a 2 right there. Then over here, this is going to be minus a. Why is it minus a? Because again, we divide this whole expression by the GCF. And what happens when you do y squared minus z divided by y squared minus z? That's equal to positive 1. So then you had negative a times the positive 1, which gives you negative a. So this is our final answer. This is the factored form of this original expression with 4 terms in it. All right. So that's just something that's factoring by grouping. But I like this problem because this problem wasn't straightforward. So this problem, we had to do a couple different things that you typically don't have to do with problems like this when you factor in by grouping. We had to switch the order around to create different groups where we would have a GCF. Then we had to do the trick with the factoring out. I call it the negative 1 factor trick. We had to do that, right? So we had to do that too. And I like problems like that because sometimes. But if nobody didn't tell you about those tricks or those strategies, you wouldn't know how to do it. And you sitting up there thinking algebra is really hard. Nah, algebra is not hard. Just ain't nobody tell you how to do it. Everything is difficult if don't nobody tell you how to do it, right? If don't nobody tell you, oh, you got to switch the terms around sometimes, then you wouldn't know to switch the terms around sometimes, probably. Or, oh, how can I get a GCF out of the binomial if they're not exactly the same? You can't. But what you can do is factor out a negative 1 like I did right here. But if ain't nobody ever tell you that, then how you going to know to do it? So I say all that to say, algebra is not too hard. It's just sometimes maybe somebody didn't tell you what the steps were, what the necessary steps were. All right. But that's why you should be subscribed to this channel, because on this channel, I tell you what to do in order to get the correct answers. And I make it make sense and I make it easy for you. But now you got to go practice doing some of these problems by yourself. All right. And before I go, I also want to give a shout out to Martin Delany, right? If you're not familiar with Martin Delany, get familiar, go do your research. He wrote several books too. Read some of his books. Marcus Garvey, of course, right? The Honorable Marcus Mosiah Garvey started the UNIA ACL, right? And also Malcolm X, of course. 3 great Black nationalists / Pan-Africanists, right? That we should study and we should know about. All right. So go practice factoring by grouping. Hopefully you find some problems that are more challenging like these where you got to switch the order around of the terms and you might have to factor out a negative 1. You have to use the factoring out of a negative 1 strategy or whatever we want to call it, right? And also study Martin Delany, study Marcus Garvey, study Malcolm X. Peace.